All right, let's dive right into this explainer. Think of this as your ultimate structured exam playbook for mastering linear functions, literally taking you from absolute beginner to advanced levels. Whether you're prepping for a massive upcoming math exam or you honestly just want to finally understand how to decode the grid, you are totally in the right place. We're going to break down everything you need to know about straight line graphs, and we're going to do it visually without getting bogged down in all that confusing mathematical jargon.
To make this super easy to digest, we've broken this review session down into 5 distinct levels to gradually build up your confidence. We'll start with the foundation, move on to core mechanics, tackle some advanced maneuvers, review a survival guide for test day, and then take on the final boss.
So, let's jump straight into level 1, the foundation. This is all about getting our bearings on the Cartesian plane.
Okay, if there's one absolutely crucial takeaway here, it's that anchoring yourself to the origin is the absolute key to successful graph interpretation. The origin, 0, 0, is the exact intersection of your horizontal x-axis and your vertical y-axis. It's the starting line. It is the absolute anchor for every single ordered pair you will ever plot. If you don't start counting your horizontal and vertical steps from this precise spot, well, your entire graph is going to be totally off.
But before we can run, we really have to walk, right? And that means understanding that every linear equation simply represents a straight line, period. Take the classic foundational formula, y equals mx plus c. In math terms, this is just a rule describing a relationship where one variable changes at a constant rate relative to another. But honestly, whenever you see an equation in that format, your brain should immediately just visualize a perfectly straight line.
And here is the classic 1-2 punch of plotting a line from a table of values. Let's say you're given an equation like y equals 2x plus 1. The process is super straightforward. First, just pick a few easy x values like -1, 0, and 1. Plug those into your equation to calculate your matching y values. Boom! Now you've got a set of ordered pairs. Step 2. Plot those points by counting from your anchor, the origin, and just connect them with a ruler. It really is that simple.
Moving right along to level 2, core mechanics. Now that we can plot points, let's actually decode the DNA of these lines.
Now this is where it gets fun. We can actually think of the gradient, which is the m in our equation, as a hiking trail to help us easily visualize the steepness of a line. The gradient measures both direction and steepness. And here's a pro tip. Always read your graph from left to right, exactly like you're reading a book. If the line is going up, that's a positive gradient. Imagine a really strenuous uphill hike. But if the line is dropping down from left to right, that's a negative gradient. Picture a fast downhill ski slope.
If you keep those simple visual analogies in your back pocket, you can instantly identify line features by sight without even touching a calculator. For instance, the y-intercept, our c-value, is just the exact spot where your line literally crashes into the vertical y-axis. What about horizontal lines like y equals 3? Well, they have a gradient of 0, so that's just a flat, boring walk. And a vertical line like x equals -2? That's a sheer cliff. Its gradient is completely undefined. Sizing these features up visually is going to save you so much precious time during an exam.
All right, time to level up to Section 3, Advanced Maneuvers. This is where we work backward from a visual graph to find the actual algebra.
Let's look at a worked example. Here is your exact algebraic blueprint to calculate the gradient and find the full equation using just 2 points. First up, find your steepness. Let's say you have the points 1, 2 and 3, 6. To calculate that gradient m, you take the vertical change, which is a rise of 4, and divide it by the horizontal change, a run of 2. 4 divided by 2, and you've got a gradient of 2. Once you have that, step 2 is a breeze. Just plug your new m and the coordinates of one of those points straight into y equals mx plus c, and you can algebraically solve for c.
Now, in advanced exams, you are definitely going to be asked about line relationships, especially parallel lines. Visually, you can spot these easily. They're like train tracks that never ever cross. Why? Because they share the exact same steepness. If you see two equations, say y equals 3x plus 4 and y equals 3x minus 10, the fact that both have a gradient of 3 tells you the whole story. They are perfectly parallel.
But what happens when those gradients are different? Well, when two lines finally do meet, reading that exact intersection point gives you the simultaneous solution to both equations. Guys, this is a massive shortcut. Instead of grinding through complex simultaneous algebra, if you just graph the two lines accurately on the same grid, the single coordinate point where they cross is your golden answer.
Okay, let's jump into Section 4, the survival guide. High-pressure tests can be super stressful, so let's bulletproof your strategy against common traps.
Here is a quick checklist of common exam mistakes to avoid. The biggest one, swapping x and y coordinates under pressure. Always remember the elevator trick. You have to walk straight into the elevator, that's your horizontal movement on the x-axis, before you can actually go up or down the shaft on the y-axis. Getting that mixed up is such a preventable trap.
When the clock is literally ticking down, take a deep breath and use sight reading as a quick sanity check for your math. Think about it. If your algebraic calculation spits out a positive gradient of 2, but a quick glance at your graph shows a line sloping steeply downhill like a ski slope, you instantly know you dropped a negative sign somewhere. Always trust your eyes to double-check your algebra.
And here we are, Section 5, the final boss. Let's do a rapid-fire practice quiz to lock in absolutely everything we've covered today.
We'll start with a beginner-level question about our anchor on the grid. Take a split second to think. What are the exact coordinates of the origin?
Spot on! The origin is always 0, 0. It's the absolute center of your coordinate plane, and the starting point for every single graph you draw.
Okay, leveling up to intermediate. Does the line y equals negative 4x plus 2 go uphill or downhill from left to right? Think back to our hiking analogies.
Downhill is correct. Because of that negative 4 sitting right in front of the x, this line represents a fast downhill ski slope. Sight reading that negative gradient is such a powerful tool.
Now for the final advanced level question. Are the lines y equals 3x plus 1 and y equals 3x minus 5 parallel? Take a good look at the DNA of those equations.
The answer is a resounding yes. They both have a gradient of 3, meaning these train tracks will perfectly follow each other forever and never intersect. They start at different y-intercepts, sure, but their steepness is absolutely identical.
Well, look at that. You have successfully navigated all 3 tiers of linear function mastery in this review session. You went from beginner point plotting to intermediate sight reading, all the way up to advanced algebraic calculations and finding intersection points. You are officially ready.
As you head into your exam, keep this final thought in mind. Graphs aren't just arbitrary, boring lines on paper. They are powerful visual stories about how the variables in our real world connect and interact at a constant rate. You now possess the ultimate playbook to read those stories. So the only question left for you is, what relationship will you decode next?